Bismillahirrahmanirrahim. I am Khadija Kanwal, Assistant Professor, Institute of Computer Science and Information Technology, the Women University Multan. Today the topic of my presentation is deep learning using isotroping, Laplacian, eigenvalues, interpolator bindings, and Kanwal determinants with knob mapping for large-scale image retrieval. This is the outline of my presentation. Abstract of my article. This is actually my research paper, which is I'm going to present here. Abstract of my research paper is CNN are relational with grid structures and special dependencies for two-dimension images to exploit location adjacencies, color values, and hidden patterns. CNN use sparse connections at high level sensitivity with layered connection complying indiscriminative disciplines with local spatial mapping footprints. This fact varies with architectural dependencies, inside inputs, numbers, and types of layers, and its fusion with derived signatures. This research article focuses the gap by incorporating these three architectures with maximum response-based eigenvalues, textures, and convolutional Laplacian scaled object features with mapped color channels to obtain the highest image retrieval ratio over millions of images from versatile semantic groups and benchmarks. Time and competition, efficient formulation of the proposed model is a step forward in deep learning fusion and smart signature encapsulation for innovative descriptor creation. Introduction. This model is related with the CBIR, content-based image retrieval. This is the query image, which is used for finding. Feature extractions will be applied on it, then features matching. For feature extraction, this is the image datasets. Feature extractions, then features database, it will go to the features matching. Then all relevant and related images with the query image will be retrieved. Now we'll talk about the artificial intelligence and machine learning. Artificial intelligence and machine learning based CNN research has fascinated significant consideration. Due to the highest performance, CNN is applied in different fields like image detection, image classification, natural language processing, and image tracking. These are the CNN architectures. AlexNext was a good breakthrough. Then VijaNet was developed for the large-scale image classification. GoogleNet applies to combine the inception modules, including concatenation operations, convolutions with different scales and poolings. Recently, ResNet is introduced with more than 100 convolutional layers. The number of trained weights are increased with number of increasing layers. This requires a huge amount for competition and significant computational time in training and the classification steps. The classification for these networks in the real-time applications is also a good challenging task. The CNN architectures are employed for highest level of abstraction using deep learning architectures that are combined for many nonlinear transformations. Image retrieval. Image retrieval is a process of image extraction based on salient image features, namely shapes, textures, colors, and objects. Image retrieval system focuses on foreground and background image features with their semantic interpretation and special aspects. CBIR is an intelligent image extraction system that retrieves the results based upon the actual image contents as contrast to text-based retrieval. Features extraction techniques. We have 6 feature extraction techniques that are extensively applied, including image segmentation, color features, shape features, texture features, interest point detectors, and combination of visual features. Color space techniques is used to convert color bands, having this representational frequency, color histogram for the multiple objects with similar color are focused with large image datasets. Texture features are extracted by incorporating various techniques which are invariant to shape and rotation. Special texture features face complex indexing and searching process. It applies spectral texture methods for image transformations on frequency image domains using special filter bands. Literature review. Brief review related to my research article. CNN have been researched by many existing methods to achieve highest performance for different applications. The recent trends are focused on understanding the DNN performance for different complexity levels. A novel technique is presented to show the minor changes in results of image classification. The researcher introduced feature extraction techniques for image retrieval and image representation using CNN. Experimentation has been performed on different benchmarks. Factorization performed on similar pairwise semantic matrices into hash code approximation for training images. For efficient and effective image retrieval, CNN is used to make binary hash code. FUN technique presents the ResNet, VJJ, and GoogleNet models with an interconnection. The SVM and random forest techniques are applied for image classification. An approach is introduced that is based on deep learning using 5 stages like image preprocessing, pre-trained CNN, semantic segmentation, query analysis, and image retrieval. New technique is performed for comparison and dissimilarity for the latest CNN algorithms like AlexNet, VJJNet, GoogleNet, and ResNet. Different algorithms and methods are proposed for feature extraction, description, detection, and object detection and classification. The CNN is applied for image classification to retrieve images using cosine similarity. A robust technique of CNN and sparse representation was proposed. Many techniques presented with in-depth feature extraction using CNN and increase image retrieval accuracy and speed using sparse representation. The recent research deploying CNN for various types of object-based image classification. The problem statement. It is difficult to recognize the shapes and objects in tiny images such as FAR10 and FAR100 databases having 60,000 images in each. Large-scale image retrieval based on deep learning consumes considerable difficulties in distinguishing primitive image features. Basic and conventional image retrieval algorithms and techniques are not effective in deep image retrieval, where minor change is observed in the mimicked image categorization. This is the proposed methodology of my research paper. Here the query images, and these images will be converted into the grayscale images. Multi-scale filtering is applied to obtain the deep image filtering at various abstract levels. These features are aggregated with gray level convolutional features which are concatenated with the first order partial derivation. Gaussian derivation, Gaussian filters whose results are purified with Laplacian of Gaussians to produce the result on which isotropic filtering is applied. Bag-of-word kernel function is applied on which NMS is performed. To create the basis for interpolation of corner responses. After the computation of determinants, here, again convolution and derivatives are applied. But the difference is here, first we have calculated the first order derivation. Now we are calculating the second order derivation to obtain the better differences. LOG approximation. LOG approximation is applied for scale spacing. These features are representative of object on parallel RGB color channels are computed with the selection of color coefficients and normalized values mapping to get the color features. At these steps, texture features, object features, color features are extracted, which are concatenated with the CNN-based trained feature vectors. The final assembly of the feature vector is the representation of textures, objects, colors, CNN-based image features for all strong image content candidates. Finally, for the image retrieval, the bag-of-word architecture is applied to retrieve the relevant images. The GoogleNet, ResNet, VJJ19 architecture return the feature vectors for each image, which deep features have already been fetched. Our contribution. It comprehensively analyzes and collects image contents such as colors, objects, textures, shapes, and spatial information, which produce significant recall and precision ratios. To obtain better improved results, a method is introduced that improves the capabilities of the ResNet 50 architecture, VJJ19, and GoogleNet architectures using its internal coupling. First time, proposed a technique that performs multi-level scaling, suppression, interpolations, determinants, and scaled spacing collectively to attain the detail of deep, finer image contents. These are 10 datasets which we have used for the experimentation and show the results, better results of our proposed method. These are the experimental results. This graph is the average Persian graph of CIFAR-10 database. The images are classified accurately due to CNN features applied in presented approach. Gaussian filters and NMS with deep learning features make possible to efficiently classify the images from the huge range of images of semantic groups. The proposed method shows average Persian results for the CIFAR-10 datasets using ResNet 50, VJJ19, and the GoogleNet. This figure is the mean average Persian of CIFAR 100 datasets. Here you can see that the lowest ratio using using presented model is the 0.81 and the 90%, 98%. This is the 98% ratio when we have fused our algorithm with the ResNet 50 architectures. We obtained the better results, highest result of the mean average Persian. Performance of the Oxford building datasets. This table is showing the average Persian ratio, first column. The second is the F-Meyer, and the third is the ARP, average retrieval Persians. The averages results are very good in all the categories of the Oxford building datasets. In few categories, the results are less than 65% due to complex and cluttered images. This is the average Persian ratios for Coral 1000 datasets, and this is the mean average Persian of the Coral 1000 datasets. And this graph is related to the average Persian ratios for Coral 10,000 datasets. We can say that 10K datasets. You can see here the results are more than 60% in all these three architectures. When we have fused our algorithms with these three architectures, we obtained very improved results. And most of the cases, the results are more than 90%. This is showing the robustness and versatility of our algorithms. This figure is related to the mean average Persian of the 17 floor datasets. Here you can also see that the mean average Persian results are not bad. These results are also good. The highest results are in ResNet 50, that is 84%. And this figure is showing the average Persian ratios for the Caltech 256 datasets. In this, you can also see that in all the categories, the results are very good. Comparison with state-of-the-art research methods, we have also compared our results with the previous results. This is the mean average Persian for FTVL typical food datasets. You can see that the proposed method in this color, proposed method is our presented method, is show the mean average Persian ratio, highest average Persian ratio in most of the categories. And mean average Persian ratio is also good of our proposed method. This table is related with the mean average Persian ratios of the FTVL. You can see here our presented method is 96%. Average Persian of Coral 1000 datasets. We have compared 9 to 10 existing works with our presented work. You can see here that is the average Persian ratios are very high in most of the categories of these datasets. The mean average Persian ratio is also good of our presented method. The mean average Persian of the Coral 1000 dataset. You can see here the 91%, and all others are less than 85%. A mean average Persian of CIFAR 10 datasets. This is our proposed method, that is the 90%, and all others are less than 90%. And 17 floor datasets, mean average Persian, you can see here the presented method mean average Persian is 84%, and all others are less than 75%, which shows the robustness and versatility of our presented method. Conclusion, this research presents a novel interactional fusion of GoogleNet, VGJ19, and ResNet 50 with an innovative salient anchor collections and detection framework to enhance the image retrieval accuracy over large datasets. This innovative deep learning solutions is a breakthrough in the framework capsulation, features binding, parameter features fusion with layer technology, deep features orientation, and CNN type effects on revealed local and global signatures. The significant outcomes with extensive experimentation from benchmark architectures endorse the superiority of presented approach with highly recognizable datasets, and extensive to this research is the fusion of several formulations. These are the references of related work. Thank you so much for your attention. If you have any question, please ask.